Thanks. Thanks, Martin, for introducing the person who will be introducing speakers. I'm really happy to introduce Jess, if you would like to come over, our first speaker of the day. Really excited to see. We have a great line of speakers today. Really excited to learn about lots of things. And as Fernandez said, excited to connect with everyone. So Jess is our expert for AI. Jess just told me not to say this, but I think I need to stick to the facts. Jess is our expert in UX of AI, lead a team at UX expert, researchers, interaction, visual and motion designers, prototypers, and PM in research and machine intelligence group at Google. He's also UX lead for AIY project that JG referred to, and also to bring AI to the maker community. And as you heard, he's the lead of Pair Initiative. Before joining to Google, he was at Amazon and Microsoft. Looking forward to hearing about how he will make human center of machine learning.
Thanks, Bean. Does this mic work? Oh, good. Jeez, I didn't want to have to hold the mic. Good morning, everybody. So I'm going to talk to you a bit today about a concept that we've really developed internally, but has developed in, I think, a lot of different locations as well. It's something that we call human-centered machine learning. And this is a lot about how we do the work that we do when it comes to machine learning or AI to make, oh, sweet clock, to make sure that we have a human-centered focus in everything that we do. So Bean kind of covered a bit of this, but I kind of wanted to give a little bit about what I do on a day-to-day basis, because I think that that helps inform why some of the statements I'm going to make sense. So the first is AIY projects. You all got one of these in your little swag bags there. So you have a little kit. You can, if you have a spare hour or two, you can put together our little kit, and all of a sudden you'll have a little Google Voice Assistant that works. Kids love it. People who like to hack on things love it. People like to mod it into all these different ways, and I'll show an example of that a little bit later. But one of our goals with that is really, how do we democratize AI? How do we lower the barriers of entry so that we can get more people involved and kind of change what it means to be an expert in this space and bring more kinds of domain expertise to the table to think about machine learning and AI. I think this has pretty well been covered. I'm also one of the leads for the Pair Initiative. I think we're good there. And so recently, as part of the announcement, we did this blog post. So my colleague Josh Lovejoy and I wrote this Medium post about kind of coming out with human-centered machine learning. This has unfortunately got us this like Bean said, like this expert label, which I really feel like this was us kind of saying, hey, we did a bunch of stuff that we tried, and like half of it worked and half of it didn't, and kind of here's where we are. So to kind of expectation set, like, this is where I think we are right now about what I've come to call the UX of AI. I think we're all kind of trying to figure it out. If you've ever wondered, this is what you get if you Google early 90s internet and actually have Creative Commons come up. I really wanted the twisting letters, dripping blood, but couldn't get that. So this is part of the expectation setting. I don't think anybody's an expert. I don't think anybody has a lot of these things figured out. I think what we're all doing right now is really experimenting with a lot of different options. And I think we're going to look back on a lot of what we did during this period and kind of laugh at this kind of stuff. So what I'd like to do with the talk today is actually kind of talk about how developing systems that use machine learning or AI typically work today in industry. Obviously, I'm going to do a bit of a caricature, a bit of a cartooning of this, and then also kind of juxtapose that with how we might actually take a more human-centered approach. So I'm a psychologist by training, user researcher is my day job, and so I tend to look at these things through the human-centered design process. And so, typically building any kind of machine learning system requires, 1,000 little decisions along the way, but there's a couple big ones that happen. And so, again, let's just kind of say this is kind of how things work today. So a lot of times, somebody or a team will find a data set, because that's actually one of the hardest things, especially if you're using a supervised learning task. Then you find a problem that is related to that data set. So you go, okay, so I have data. Now what kind of problem could I solve with that data, or model could I build? You train a model, or you kind of like extend an existing model or do something there. You look at the performance of that model. You kind of squint and say, yeah, like 70% accuracy sounds about right. Like, it would be hard to do more. And then, you launch the world's first smart whatever that you're building. Next step is kind of profit. And this is a very kind of like tech-forward way to look at things, and I think it reflects actually the complexity in the problems and the difficulty developing here. And so, the question mark slide. So what if there was a different way to do this? What if we actually started to take a lot of what we've been using in the UX field for a long time around human-centered design, and we approached machine learning development through that lens? And so what I'd like to do is kind of walk through a couple examples of kind of today and what it would look like in a human-centered approach. A lot of what I'm going to talk about as well, I just kind of want to caveat a couple things. One is a lot of these are ands. Some are not full replacements. It's like, what if we did that and we did this? The other is, I apologize, it's a little heavy on the Google examples. I won't say I'm not biased. Obviously I'm biased, but those are just easier to get through the legal review and everything like that. So forgive me a bit for that. But first, I kind of want to start about like what human-centered design is. If you Google that, there's lots of explanations. It kind of comes down to 5-ish so big things, and I'd like to actually put a different kind of spin on some of these. So one of the first things is we talk about like getting proximate and staying proximate. This means truly knowing the people that you're building something for. One way I'll put it is, if you don't know what your user's breath smells like you don't know your users very well, right? Like you need to be with them, empathizing with them deeply and working with them. Another is what we call like inclusive divergence. So this means really reaching out into lots of different ideas, but making sure that you're being inclusive and bringing the right people in and the right perspectives and the ones that might not be easily accessible to you. Commonly, there's a shared definition of success. So we do a lot of this in the beginning of like, what does it mean to be done and to be done right? And is that something that our customers or users will actually be able to articulate back to us or will be able to measure easily? It's making early and often. It's just making stuff, prototyping, going through it, and then iterating, testing, and the really important thing is throwing away. Is literally, not trying to reuse code, not trying to do something, and just getting rid of it, and being okay throwing something away and moving on. And this is, some of these are used in some machine learning development now, but a lot of them aren't. And so that kind of brings us to, okay, so then what would a human-centered approach to machine learning look like, and how might it juxtapose with what happens today? And so I'd like to kind of walk through some examples there. So I mentioned, like today, you kind of find a data set, then you find a problem, and it's even better if it's already one of these public data sets out there. A human-centered approach would be to find a problem and then match or create a data set to solve that problem. So this is an example of an app that actually was trained to identify diseases on plants. So you can use computer vision, you can take a look at this, it'll give you an approximation of what the disease is, and then you can actually contribute your photos as well to their data set to make it better. This is like, I like to focus on what I call like problems before the software. Like this isn't a tweak on a software problem that came up. Like having to take care of plants and identifying plant diseases is a very, very old problem, and being able to help people with that is a really is a very important contribution. More broadly, I actually think machine learning and AI could be more widely applied to agriculture, specifically people growing their own food. There's a wealth of data there that could look at ways to improve crop yields, reduce the need for pesticides, more optimized resources. Again, this is one of those problems of people being able to feed themselves and their families healthy foods is a pretty worthy goal, and one that I think that we could be addressing. Here's an example from a BBC documentary about a woman with Parkinson's. So there have been some efforts lately to actually help people. You may have seen like the balancing spoon that actually kind of counters some of the movements that come from the Parkinson's. And so we look at these where I'm unaware of any of them using machine learning at this point, but you could imagine, one of the great powers of machine learning is the potential for deep personalization to an individual. And something like this, like literally to a human's movements, could really help to stabilize their movements and help them kind of get on with the rest of their life. The next one is, today a lot of times we'll find a bias in data sets after a problem is discovered. If you're not familiar with this image, this is from the ProPublica article that was, I believe, almost last year now, that was looking at algorithms that were trying to predict recidivism in criminals, and it basically said that all other things being equal, black defendants were almost twice as likely to be considered high risk for recidivism relative to white defendants. And so this, was exposed and the bias in the algorithm was there. But it kind of had to happen first. And so what we want to move to is a way that we can more proactively inspect data sets and intervene. This is facets again, sorry to reuse the same example, but it's an interesting way to say, like, we're building out the tool set so people can actually proactively do these things before something is released into the world and before it can affect people's lives. Today, models personalize experiences, right? So you have a model, it adapts something to you. This is an example from Gboard, so it's going to adapt using its language models to be more personal to you. And there's a really interesting way that this is a lot of kind of passive input into the model, and it's adapting to you. But there can also be examples where people might be able to personalize models more themselves. So this is an amazing example I found. This is from a data scientist named Dat Tran. Dat, if you're watching, thank you for letting me use your example. So he built a raccoon detector. Because he actually, I think he has a pet raccoon, or he has raccoons in his backyard. He actually labeled some data himself, but he was able to kind of take existing models, do a little bit of work to extend them and create the kind of model that he precisely needed himself. He had to go through a very heavy developer experience to do this, but as Martin and Fernanda hinted at, we're heading towards a place where you could imagine that people could take a model that generally does what they need and perhaps actually be able to extend it or tune it to a use case that's very personal to them. So maybe not every raccoon detector, but this particular adorable raccoon with them sweeping up the place. Today, for a lot of these models, we have to centralize data, and we have to do that to require to get the benefits. That often, obviously, happens in the cloud some way. In the future, in a human-centered way, I think that we can have improvements where we can start to use the cloud in addition, along with other technologies like federated learning that allow for more decentralized learning of the models and really kind of give everyone a lot of the benefits of AI and machine learning with additional privacy. Again, this is kind of a together part of this, but I think that we're seeing some good innovation here. Today, there's a small group of experts. This is apparently, I know this isn't all the experts, but this is the image that comes up of deep thinkers about deep learning, apparently. And you got some famous people in there. It's a pretty good shot. But in the future, how might we actually expand machine learning and connect it to more kinds of domain expertise and create more makers? So this tweet was my favorite after we had our AIY launch back in May. So Stephen here said, had fun building the AIY project this weekend with my son, his first electronics project. And that really blew my mind. So the very first project that this kid built used AI. Like, that's his framing for making for the rest of his life, probably. And I think that's really profound. Like, he's never known AI at this point as like an other or through some kind of pop culture lens or something like that. Like, he was able to control it from the beginning, and it was able to do what he wanted it to do from the beginning. And I think that we have an opportunity to kind of create a wave of a generational wave of how people will approach and think about how they're going to use machine learning and AI in their life. I think we also have a lot of opportunity to do better crowdsourcing of data and for people to be able to share data with each other and to help each other's lives. So this is the Crowdsource app from Google. So this is available for download today. That sounded like a pitch. So you can basically choose from a variety of categories, and then you can go through examples, and you can kind of say, yeah, that's a picture of a girl. No, it's not. I do the sentiment analysis one every day, so I actually get a little notification, and it's just like, is the sentiment in this positive, negative, or neutral? And now I kind of do it every single day. I think it would also be really interesting to marry this with some notions of contests, or a concept I've been kind of talking about a little bit with people. It's kind of call it blitz training, which is this notion of could we actually very rapidly improve the quality of certain models in very specific cases? One of the examples is, if there is a flood or something like that, oftentimes our translation models are good, but they're not equally good across all language pairs. So if we saw, which country was coming to the aid of another country, could you actually essentially power up the quality of that model very, very rapidly by basically calling the community together to give more examples and to refine the model. And then you see more of these examples too of kind of community-sourced data sets. So the open speech recording there, that's something by Pete Warden, looking at can we train models that could run offline as well. So people can donate your voice samples. So basically get like 100 words. It's actually 20 words that you say 5 times. So you speak them in. It's used as a training set for that model. And then that little robot there is from Mozilla's Open Speech project, which is similar. One of the other benefits of this is, one, is that things can run on device, but 2, you can create a much more inclusive data set. So this is that inclusive divergence I mentioned earlier. You're able to kind of fan out to make sure that you're not accidentally introducing bias into your data sets too early and giving people access to influence that. You know, today there's narrow training and testing of models. So this example is trying to build a sentiment analysis tool based on product reviews. So you can kind of imagine that something based on product reviews might have a certain tone or sentiment to it that may not be as generalizable to the rest of life. And in the future, I think we're just entering into this phase of like we're judging things by real world impact and by how they materially change people's lives. So this is one of these headsets that is for people who are visually impaired or people who are blind. That will allow them to use object recognition or OCR to recognize things in their environment, or to, obviously anything printed. And I'll come back to this example in a little bit, actually. Another really big real-world impact, I think, is the translation work. There's almost nothing more fundamental than being able to communicate with other people and to be able to understand the world around you. And I don't think it's just about efficiency or information consumption, but that can also be a lot of feelings of safety and feelings of belonging in different places. So today, you know, we do machine learning, and I put in parentheses once. So does everybody know the pick bot that kind of just runs random images on the internet through some of the image recognition software, and then it tweets it out? And sometimes it's good, and sometimes this is like the canonical funny example. So it says, you know, essentially like, what do you think is in this image? And it says a dinosaur on top of a surfboard, which is kind of like the hilarious, like, yeah, I kind of see how you got there, but like that's as far as I can tell, that's not a surfboard. And so I think what we're going to move into is really more of a model of human learning and, machine learning and teaching. So these are some of the examples from the Sketch RNN work. Where people can actually use human input in the machine. The algorithms then try to reconstruct whatever the person put in, and you can see there's kind of these funny examples where, you know, you can give the one second from the right there is you can give a pig with 8 legs, and it's going to try to actually pigify it a bit more. You can kind of play with it and try to trick it a bit. And then this is another example there where you can actually start to put in an example. So the human is, you know, giving an example of what a cat drawing is doing here, and then the neural net is actually kind of generating alternatives on this. So I think that there's a lot of really interesting work, and you're going to hear from Doug and other people that are looking at this about how do we actually use algorithms for creative purposes and for expanding and for augmenting our creativity rather than, you know, anything replacing it. Another example of this is, I think this is really interesting, this is an example of using panoramas from Street View and trying to train a model on what basically professional photographers did, and then zooming and cropping in on some of these images. So below is kind of the general image, and the model basically said, actually, I think if we zoom in on that house in this part right here, you're going to see a much more beautiful image, and, you know, it's pretty good. Might hang it on the wall there. But I think one of the things that we're looking at is actually how do we work with people and learn from expertise, and how can we turn some of that expertise into algorithms, but also augment that expertise with algorithms. And then the really, really easy one is sometimes you have forms, so people can give feedback on things. So this is how Google search works. You know, you can report an auto-suggest, and you can just say, you know, this is hateful, sexually explicit, violent, whatever it might be. So today we have lots of automation, and oftentimes automation is the goal of a process. And this is a really funny video that I really hope loads, but may not load. Is everyone familiar with Simone Giertz? Yeah? Gertz, thank you. Oh, this is going to be disappointing. Anyway, she built, there we go. So, exactly how I planned it. So she builds, she's known as the queen of the shitty robots. So she builds kind of like unnecessary robots, or robots that kind of do their jobs quite poorly. This was supposed to be a hilarious example of automation gone awry or unnecessary automation. This is her breakfast robot doing its best. The deadpan with the book is fantastic. There's the spoon. And if you haven't, you should definitely check out her YouTube channel. There's a million of those. All right. There we go. And I think that we want to start thinking a lot more about human-centered augmentation, as we've been talking about. One of the ways we kind of think about this is examples where something is already an extension of self. So you'll hear, a fencer or somebody like that talk about how the sword is more of an extension of them than another tool. Another example I really liked about this, I found this Joan Jett quote where she was saying, my guitar is not a thing, it's an extension of myself, it is who I am. And I think that's a lot more interesting way to think about some of these technologies. And this kind of brings us back to the head-mounted display, right? When the slide advances, of how do we extend, there we go, how do we augment that person's experience so that they can recognize people in their environment or text that they're coming across. And I'm out of time, so I'm going to see how quickly we can get through the rest. And so this is actually one of these things of, if anyone's read Calm Technology by Amanda Case, she kind of talks about this, about how these technologies and the augmentative technologies might kind of become mainstream and get into the world. And one of the examples she uses is glasses. Nobody sees glasses as some kind of weird cheat or advantage in the world. It's a way to actually kind of make somebody whole, in a sense, and to augment their experience. And so she has a really good quote about this that kind of says, it's a lot of times it's about expanding people's definition of normal, which is always a very gradual process. But I think that that's what we'll see, is a normalizing of people using AI and augmenting themselves with these technologies. So just coming back to here, I think the approach we can take is one that we've taken in human-centered design for a long time. We stay proximate to people. We have inclusion while diverging and thinking of different ideas. We share definitions of success that are rooted in the real world. We make things early often. We iterate, we test, and we throw them away. And I think that that will lead us, from where we are kind of here into kind of where we want to be. Thank you very much.
Awesome. Thanks, Jess.
Yep.
Is there any questions in the audience?